Hi everyone, welcome to this information session for engineering. Sorry about the weather today, but welcome to the campus of the University of Melbourne. My name is Mark Cassidy, I'm the Dean of the Melbourne School of Engineering. We hope you're going to enjoy Open Day, but of course the main reason we're here is to hear about our courses. So today's session will cover engineering here. But before commencing the session, I would just like to acknowledge the traditional owners of the lands that we're meeting on today, the Wurundjeri people of the Kulin Nations. I pay our respects to their elders, both past and present. I also pay my respects to all Indigenous Australians attending our sessions here at the University of Melbourne today. So the University of Melbourne School of Engineering is the oldest engineering school in Australia. For over 150 years, we've been driving engineering and IT innovation. Our curriculum is focused on creating the leaders of the future. And to talk about today, I'd like to introduce Associate Dean for Academic, Professor David Shallcross, and he's going to overview the courses. David.
Thanks, Mark. It's a great pleasure to be here with you today. So the structure of the day is that we have this general presentation talking about engineering, and we have a number of presentations talking about the different disciplines of engineering. Okay, so be mindful of that. We've also got some demonstrations. We've got some, you can get one-on-one advice over in old engineering. So I'm a professor here. I'm Associate Dean Academic. I'm also a professor in the Department of Chemical Engineering, so that's where my background is. So as you've already heard from our Dean, a special welcome to everyone, and we welcome students from all around the world into our programs. So what is engineering? Well, we've got these definitions here. It's basically to make use of our understanding of the underlying principles of the way in which the world works in terms of maths and physics and chemistry and biology, etc., to solve problems using that knowledge with judgment, okay, to try to make it a better world, as we've got up there. So we create solutions to a whole range of things, including infrastructure, information technology, communications, transport, fuel, energy, biotechnology, all those sorts of things. Now, at Melbourne, we are world leaders in a whole range of different areas, and, we've put up some of those things up there. Number two is something that I know a little bit more about because it comes out of our department, and that's keeping Antarctica clean. And so, over the decades of exploration down in Antarctica, what the Australia used to do is to get rid of the rubbish. They dug a big pit and they put all the rubbish into the big pit. Some years later, they thought, that's not a good idea, so what we're now going to do is bag all our rubbish up down Antarctica and bring it back to Australia every year. And they did that. Then someone thought, actually, we should excavate those rubbish tips and take that back to Australia, and they did that. But in the intervening time that rubbish was buried, you actually had contamination of the groundwater. And even though it's down in Antarctica, you might think, well, no groundwater. Yes, there is groundwater that moves through the ground and will empty into one of the bays. And so we were tasked to develop a way to intercept that plume of contaminants as it moved underground through the structure, and we were able to develop a technique which allowed us to intercept that. So that's something that I know a little bit about. Certainly some of the others you can see gets very much into modern manufacturing techniques around 3D printing. We can 3D print medical devices, so say joints and what have you, which are designed just for the individual person. So that leads to low-cost prosthetics. And we're also looking at moving into something called Industry 4.0, which is, people talk about it as being the fourth industrial revolution, around artificial intelligence, around big data, and that's very much a future direction for engineering. Within our program here at Melbourne, we offer these sorts of areas. Biomedical engineering certainly is a strength which has developed over the last 10 years. Chemical, biochemical and materials engineering. So we're in the home of that particular discipline. Civil and structural engineering. I mean, one of my friends years ago, one of my colleagues used to talk about civil and structural engineering is about the design and construction of things that don't move, where mechanical engineering is around the design and construction of things that do move. We have computer science and software engineering. Software engineering, of course, is around the design of big pieces of software, be it systems that allow you to book a flight and choose your seats, and even then choose the meals you're going to have on your flight, so that when you get to your seat, they're ready to present you with your meal on a long-haul flight, for example. Electrical and electronic engineering, very, very strong in this area. Certainly in environmental engineering. A new one for this year, we've always done work in aerospace in our department, but for the first time this year, or next year I should say, we're introducing some specialised subjects in aerospace. And so that's a new discipline. And spatial information, the measurement and management of spatial information, it used to be called surveying, but it's now got so many more applications broader than just surveying. Rankings, well, we're ranked number 1 in Australia for engineering and IT, ranked number 27 in the world for engineering and IT, which we're proud of, but we're not resting there. In terms of employability, there's one of the international ranking agencies looks at employability through a number of measures, including things like the reputation of the university and the graduates, etc. We've been ranked number 7 in the world for our graduates being employable. And something like 93% of our graduates have found employment 4 years after graduation. We also have a program which is highly got high level qualifications, which is recognised globally through accreditation. So yes, be inspired, come to study with us, but our program of course is different from doing engineering at some of the other universities in Australia. So we are connected with industry. Some people, like to have this idea that at Melbourne we're very, very theoretical. Yes, we are to some extent, but we're also industry plugged. We're plugged into industry. So we've got so many of our students now going out on industry placement as part of internships or industry-based projects. Academics work closely with industry. Just as an example of that, 2 years ago, I spent 6 months on sabbatical in industry in a chemical plant out in the western suburbs, okay, to make sure that what I teach is actually still relevant. And so that was absolutely tremendous. So we have industry, lots of opportunities for students to be involved with industry. One of these is taking place under Grattan Street. Now, I don't know which way you might have come in, but Grattan Street is the street that runs east-west just to the south of the main campus. It's blocked off because they're building a metro railway station there. Now, it's a real pain to get from one side of the campus to the other. It takes a few extra minutes. But on the other hand, it's fantastic because it's a real engineering project going on in our backyards. So we've negotiated with the company that's building that to get our students involved in all sorts of ways. So as from what I understand, we've already had a class of civil students looking at the way in which the piling is being done at the moment, okay? And throughout the program, whether it's civil, structural, electrical, mechanical students, they'll be involved going on site visits. We're going to get the engineers talking to our students. So it's very much we are connected with industry. We are a degree, an engineering degree from Melbourne is internationally recognised. So our programs have been internationally accredited by a range of bodies, most notably through Engineers Australia, and then that gives us access to something called Washington Accord agreements, and then EURACE, and we were the only program we were the first program outside Europe to get EURACE accreditation, which means our graduates can work in industry in Europe and without as many barriers as otherwise might be there. And as well as that, we have other accreditations. So just looking at Engineers Australia accredits all our Master of Engineering programs, should say maybe with one exception, and that's with the Aerospace, because that's new for next year, so they've not yet accredited it, but we'll get that sorted out within the next couple of years. EURACE accreditation is given to us by a German organisation called ASEN. They came out 2 years ago, and about 20 of their people spent about 3 or 4 days with us going through our programs. So that's accredited, with the exception of the Master of Engineering Software and Software with Business, which is accredited under the Euro-Inf, which is the information side of things. Australian Computer Society, they accredit these programs. Royal Institution of Chartered Surveyors, you can see, do these, and we do have Surveyors Registration Board of Victoria as well. And finally, the Institution of Chemical Engineers, which is a British-based body but which accredits courses around the world, accredits us at their highest level, what they call M level. So any graduate will be coming out with a degree which is recognised around the world. So our programs at Melbourne are designed to be as flexible as possible for you if you're coming from VCE. If you're coming from VCE, you're not sure exactly what it is you might want to do. And so you'll come in through the Bachelor of Science pathway, and we try to keep things open for you as much as possible. And so you can focus on your preferred field right from when you come in, but we also have some pretty good flexibility. So what happens is that you can actually study for engineering at the undergraduate level, the 3-year program, through the Bachelor of Science, the Bachelor of Design, or the Bachelor of Biomedicine. Okay, so for most people, they look to do it through the Bachelor of Science. And in your very first semester, you'll be doing an engineering subject, and that's a subject that I teach. Okay, and in the subject, the first year subject, what we do, and it's one of 2 subjects, is we have a project which students have to do over the course of the entire semester. And so we lecture on doing the project. So it's very much a project-led activity. And this semester, this year, what we're doing is we're looking at supplying water to a small community of about 2,000 people. And how you would do that, looking around how you would pump the water up, how you would treat the water to kill the pathogens, and then how you make sure that it operates correctly. So if you know you want to do engineering, you'll do a couple of subjects of engineering, a couple of subjects of maths, a couple of subjects of science, and what we call breadth. So you would major then in chemical systems or civil systems or electrical systems, but once again it's flexible. So if you're not sure that you want to do electrical or mechanical, then there's a set of subjects that you can do that keeps those pathways open, okay, for as long as possible, so that you can then get to the end of your 3-year degree and then you can go into a 2-year master's. And so the master's is, when you graduate, that's your entry to practice degree. So you go to another place, you can get an engineering degree in 4 years. Terrific. Come to us. Yep, it's going to take you 5 years. Okay, but we believe that we'll be covering a lot more material and we'll be developing you in different ways than what you can do in a a 4-year program. Some of these with the asterisk, just note that we offer a with business, so you can do civil with business, electrical with business, software with business, and it just means that some of the electives within the master's program have been replaced by engineering business subjects. And then once you leave there, you go on with employment with your professional accreditation, or sometimes some people like to continue on for research studies. Okay, we're also offering something new for this year, and you might have seen it in VTAC guides. And so this is what's called the graduate degree package, which basically guarantees you a place in the masters. Okay, so at the moment, if you do the Bachelor of Science or Bachelor of Design, yes, you're in there, but you've got to average 65 or above to then get into the masters. What we're doing is saying, look, if you come into the graduate degree package, you've got to pass the bachelor's to get into the masters. Okay, so you can come into the Master of Engineering through biomedicine, through design, through science, or through commerce, should you wish. How are we going for time? Oh, it's good. So what you need to then do, if you want to come in through the graduate degree package, you need an ATAR, yes, it's high, of 96, and then you come in and you've got that package and allows you to go through. Whereas if you come in the standard entry, then you have to achieve that 65 average in your undergraduate degree to get into the masters. That's the main difference. Okay? You'll still get your CSP place, Commonwealth supported place. It's just that we've removed the barrier and we've packaged it up for you as a 5-year program. Okay, so just looking at the entry into our 4 main feeders, you can see here the sorts of scores that we've had in the past and what we're looking at for minimum. Okay, and what the prereqs are. So for many people coming through science, it's at least 25 in any English or at least 30 in EAL and at least 25 in maths methods and specialist maths and one of biology, chemistry or physics. Now, if you want to do chemical engineering, of course, we'd be hoping that you would have done chemistry. If you want to do electrical engineering, we'd be hoping you would have done physics. But if you haven't, that's okay, because first year in science will sort that out for you. Okay. Some students might want to get a commerce degree first. There's the pathway there is a little bit more complex. It just means that you'll end up doing your engineering subjects as what's known as breadth, and then you come into a 3-year Master of Engineering. So yes, it is longer. Okay. New for next year is our Master of Engineering Mechanical with Aerospace. It's not the Master of Engineering Aerospace, it's Mechanical with Aerospace. It's not a full-blown aerospace degree, but it's a mechanical engineering degree, so you graduate as a mechanical engineer having completed some aerospace subjects. We haven't gone to a full aerospace major or specialisation at this time. So you will graduate and be able to work as a mechanical engineer having done some aerospace. And then within our MIT offering, cybersecurity is our new program that's just been approved. Other areas and disciplines that might interest you. There's the Master of Architectural Engineering, which is once again a longer degree, but you're going to graduate not only as a qualified engineer, but as a qualified architect. So the pathway to that is by doing either a Bachelor of Science or a Bachelor of Design in civil systems and then going on to do the Master of Architectural Engineering. We've also got the Master of Data Science and Master of Sciences in Computer Science and Bioinformatics. And for more information on those, well, there's booths and other information sessions later in the day. Industry is very important to us. As I've already said, there's internships. These can get you credit towards your degree. We've also got industry-based projects. I've got 2 students working with the water industry this semester that I'm supervising, so they're getting great exposure to that important industry, the whole supply of water and then the treatment of wastewater. We also have a number of clubs and societies, like Women in Science and Engineering, or Engineers Without Borders, or the Melbourne University Engineering Student Club. So a range of different things, and Endeavour exhibition is a fantastic thing that we have every year towards the mid to end of October. Melbourne Accelerator program is an entrepreneurship program that we run, currently ranked 13th in the world. It supports entrepreneurs at a whole range of different stages, and it is a terrific event that's grown out of our School of Engineering. We've got a lot of developments happening at the university. The university has decided to invest around about $900 million in engineering. So we've got a site, this is the former site of the Royal Women's Hospital, that's sort of just over here. There's a big block that's been demolished. We're getting a new facility there, which will be the home of some parts of engineering. We're also building a new space down at Fisherman's Bend, which will be more for research and big pieces of equipment. So we're still teaching engineering on the main campus, but there'll be some occasions when there'll be activities down at Fisherman's Bend. So probably in buildings alone, you're probably about $500 million investment, and construction will be happening. I think, well, we've cleared the site, so they should start construction next year on the Royal Women's Hospital site. Fisherman's Bend is probably going to be not far behind it. CSP, of course, I'm sure you're aware, is a subsidised Australian government initiative. We have scholarships available for engineering and IT specific applications, as well as university-wide things.